Now, as we select and support market adjustments, let's consider a floor height adjustment. That's a common adjustment appraisers make. We're going to look at the example of an oceanfront condominium in Florida. I realize where you are, there may not be a lot of oceanfront condominiums, but there are going to be high-rise buildings in which you need to make a floor height adjustment. So that's what we're going to consider here. Now, what we're going to look at now is sales that closed in 2013, 2014, and 2015, with an emphasis on sales from 2013. This is the building in which the sales are located. You're looking at the south side of the building. Obviously, it faces east. You can see three stacks of units. The first one, the one closest to you, has the highly romantic name of the A unit. Then there's the B and the C unit. The A unit has a balcony, as you can see. It also has a balcony in the front. The B and the C units share the front balcony, but not the rear balcony. If you do not count the balcony space, they are all the same size. That is the north side of the same building. If you will look there, you will see three stacks of buildings. They have highly romantic names of E, F, and G. The E and the F are the same unit, same floor plan, same size. We are not going to look at any of the G units. That is an aerial photograph of the building. The top of the photograph is north. Therefore, to the right is east. On the east of the building is the D unit. It is a separate unit, it is larger than the other units, and while we are going to look at it for analytical purposes, it typically would not serve as a comparable sale unless it was the appraisal of another D unit. Here are the sales. Now, please note that you usually need a minimum of 30 data points to achieve what's called statistical significance. It's not always possible in what we do. There are ways to overcome that, but we're not going to talk about them today because they're outside of the scope of this course. So we're going to go with what we have. Now, let's look at this bottom graph. The 2013 sales are shown by floor. And it's clear that as your floor height increases, so does your sales price. Or does it? Let's take a look. Here are 4 pairings of data. You have 2 E units compared, 2 A units compared, an E and an F compared, and an F and an E compared. You'll notice that there is a significant floor height difference in those pairings because that is the variable we're trying to isolate. Now, if you look at the first one, there is a $4,000 difference per floor. The second one shows a $13,000 difference per floor. The third and the fourth show approximately $3,500 and $5,600 each. Now, you look at that, and we've got multiple pairings. And the reason we have multiple pairings is because without them, it's difficult to indicate market trends. And part of what a real estate appraiser does is discern market trends. 2 sales do not indicate any trends. It takes more than that. That's why we've got 4. We have a fairly tight range from the first, third, and fourth pairings, but that second pairing is just totally out there in left field. So we're going to look at it, we're going to acknowledge that it's there, but you'll see we're not going to give it a whole lot of weight. However, it's your judgment call as to what weight you should give it. That's part of your scope of work. So let's take a look at this. From this analysis, what is a reasonable adjustment per floor? As we look at these pairings, is there any non-realty present? Now, there isn't, other than furniture, possibly, but furniture in a building like that rarely has much value. Have we omitted anything from our analysis? In this particular case, we haven't. We have complied with Standard Rule 1-4. We have all the sales from 2013. Have we included anything in our analysis that shouldn't be there? Insofar as we can tell, no. We're looking solely at real estate value. Now, hang on a second, because we're going to come up with an adjustment. We're going to compare the results of the statistics from the results we got from the pairings, just to see how they complement each other, if indeed they do. Now, we're going to be looking at some graphs in a minute, but understand that the y-axis is the vertical line on the graph, the x-axis is the horizontal line on the graph, the r-squared is an indication of how well x explains y, the x in the variable is the floor height itself, the number in front of the x is the adjustment per floor, and finally there is another number which I'll explain in a minute. It's basically a minimum value, and no property can be worth less than that. So let's take a look at this. An r-squared close to 1 is an ideal, and in our case it would mean that the only reason sales prices vary from floor to floor is the floor height. An r-squared close to 0 means that floor height explains none of the difference in the sales prices. And you're going to see in a minute an example of that. Now, outside of textbooks, an r-squared of 1 is, you just don't see it. And what that means is variations in sales prices is a function of more than merely a variation in floor height. Now, let's take a look at this. We want to avoid selection bias. We've been through this before. So we follow Standard Rule 1-4 and we collect all of the data necessary to form a credible value opinion. Now, take a look at that graph. You have a red line and a purple line. Now, this graph, if you were just to look at it, doesn't really tell you very much. You'll notice that the points, the data points, are not all that close to the line. When you see that situation, what it means is there is not very much correlation between the sales. And you'll notice that the r-squared values in those two nasty looking formulas are very low. So what we have here is something that really doesn't make any sense. So we have to make sense out of it. Now, again, the x-axis is the floor height and the y-axis is the sales price. What we're looking for is the relationship between floor height and sales price. Look at the lousy r-squared value, less than 1% for the top one, less than 4% for the second one. Doesn't mean anything. But take a look at these two outliers. Those are D units. Remember I said we weren't going to use D units in this analysis, so what we're going to do is we're going to take them out. We're going to do what's called scrub the data, so that the data that we are using to form our opinion is particularly relevant. We want to make sure that the r-squared value is as high as possible, and we do that by using only relevant, comparable data. So we have to scrub out the 2D sales, otherwise they can skew the data and then skew the results. We've taken them out. Now, look at the two r-squared values. One's 28%, 29%, the other one is 45%. Not all that good, but a whole lot better. Now, what happens is the red line shows us that as floor height goes up, sales price increases. That's the relationship you'd expect. The purple line, on the other hand, shows that as floor height increases, the sales price per floor increases up to a point at about the 15th floor. Then prices start to drop. This is a function of some people just don't like heights. They'll pay a premium to be on the 10th, 11th, 12th floor, but above that, they're not terribly interested. So what we have are these two lines, the red line, the purple line. We're going to use the purple line for the illustration here, simply because it's a little bit more reflective of what the market does. Now, if you look at the r-squared value, and this happens to be of the red line, you'll see that the difference in floor height explains approximately 30% of the difference in sales prices. Whereas if you look at the purple line, that formula explains approximately 45% of the changes in sales prices as floor height changes. That's why we're using the purple one. Now, the minimum value is $329,000, meaning no property has a value less than that. So you can't adjust down or up to the point where you go below the minimum value. Now, we still have an outlier. Is that a problem? I'll give you a hint. Yes, it is, and we're going to handle it in a few minutes. So we've got a red line and a purple line, and you say, Tim, that's wonderful. What does that mean to me, a boots on the ground appraisal? Well, we're going to find out. Let's just eyeball this right now. If you were to draw a line, this happens to be the solid green line, from the 14th floor, and I chose the 14th floor randomly, up to the purple line, and then left to the value indicators, you would see that based on this analysis, a unit on the 14th floor would have to have a value above $375,000, but not all that far above $375,000. So let's take a look at the math itself and see if we can narrow it down any further. Now, this is the simple regression formula. We have A, B, and C. The X is the floor height, so X will always be 14. The A and the B come from the formula that we just looked at. So what we have here is that the value of a property on the 14th floor, when you add and subtract all the math, is approximately $378,000, and you would round that as you chose. Now, what if you chose a unit on the 21st floor? Well, looking at the same math, you'll notice it comes in at $369,000, which you might call $370,000. That reflects the arc in the purple line that we looked at earlier. What it means is people are willing to pay a premium to live on a higher floor up to about the 14th floor, and then that premium falls off. So a unit on the 21st floor has a value somewhat less than a unit on the 14th floor. Now, which of those curves will you use, the red one or the purple one? That's your choice. What that means to you as a boots on the ground of the appraiser is what you choose it to mean. When we took out the D units, we started looking at changes of about $2,300, $2,400 per floor, which, while a little bit less than what we got from the pairings, merely gives us a range of adjustments. It doesn't say the pairings is wrong, we just have a range. Now, are we going to use the average floor change difference? Isn't that appraisal blasphemy, using an average? It might be in certain areas, but it is not here, because regression analysis raises the question, regression to what? It's regression to the mean. And we're not going to get into the math behind that. That's another class. So what you choose, the adjustment you choose to use is up to you. $2,300, $2,400 a floor, $4,000 a floor, that's your choice. You're the appraiser. It's part of your scope of work. How do you handle this change in your value conclusion? As you need to. You might want to be careful about putting in too much information. It's tough to get in trouble for the information that you don't put in sometimes, not always. But you might not want to give the client too much information, but of course you're going to have it in your work file for future reference. You might ask yourself the question, what if the units are only one floor apart? Would you make an adjustment that amounts to less than 1% of the sales price? Probably not, but then that's up to you. How many floors difference would there have to be before you chose to make a floor height adjustment? Again, that's your judgment call. It's your scope of work. And then the last question you might ask yourself is, if I were on the stand, could I explain the concept of R squared so that the judge and the jury could properly understand it? If you can, great. If you can't, you probably don't want to put it in your report.